Every fellow, whether they're on the 3-year program or their 4-year program, does research. For those that are on the 3-year program, they do about 5 or 6 months of research. For those that are on the 4-year program, they do about 2 years of research.
I chose a 3-year program because I felt like for me it was the best balance of clinical practice and the opportunity to participate in research.
I chose the 4-year program at Columbia so that I would have enough opportunity to really develop my skills as a researcher.
So I chose the 3-year track at Columbia partly because I felt like I had had a lot of clinical research experiences previously in residency, and I felt like I wanted to have some extra refinement of some of my research skills, but I also was pretty confident that I was planning to pursue advanced fellowship in heart failure and transplantation.
The master's program here at Columbia was a tremendous opportunity for me. I took a year off to get a master's in public health at the Mailman School of Public Health. The biggest opportunity it gave was time to think and time to sit with experts to really understand what I was getting into, understand how to craft the right questions, get the basic statistical training, and put myself in a position where I can be a leader in the field when I completed my fellowship.
I am the PI of an NHLBI training grant that we share with the surgeons. This is a program that is designed to train only cardiology fellows or surgery residents in cardiovascular research. The cardiovascular research is either clinical or it's basic science. And the training grant provides 2 years or 3 years of funding to support our fellows' research training.
We take a different approach here at Columbia. We take the Mr. Potato Head model, which is that we think the ideal mentorship model is taking a team of mentors, making sure the mentors on the team complement each other in sort of the expertise and skills that they then can train the fellow for success. And so, just like a Mr. Potato Head, we're taking the ears from one mentor, the eyes from another, the hair from another mentor, and we're creating the ideal Mr. Potato Head mentorship team.
Yeah, so we have a variety of support, both from NIH funding. We have a large R01 and currently an R21 that supports us. I'm personally funded by a K24 mentorship grant and take a great interest and pride in kind of advocating and working with the fellows.
We're very fortunate at Columbia because we really focus on cardiovascular research. Now that can be clinical research, it can be basic research, it could be preclinical animal research as well. We're also fortunate to have as our sister organization the Cardiovascular Research Foundation, which is really a repository of dedicated people whose only purpose is to forward cardiovascular research and education.
For fellows that are interested not only in interventional cardiology, but any aspect of cardiology that abuts interventional medicine, there are a ton of research opportunities. We're involved in a lot of FDA trials for device approvals, but also NIH trials, and even retrospective analyses. And so we've had fellows work on projects where they analyze existing databases, but also be involved in prospective studies, also be involved in regulatory processes, which is a very unique experience that we offer at Columbia.
With Dr. Leon and Sushil Kadali, who heads the Structural and Valve Center, the innovation that comes to Columbia is something extraordinarily unique.
My research focus is really on diseases that disproportionately afflict older adults. You can name almost all of those, but in particular heart failure in the setting of a preserved ejection fraction, with a particular focus over the last decade on cardiac amyloidosis, particularly due to transthyretin amyloid deposits.
I am an NIH-sponsored physician scientist, and I perform research on the basic science of cardiac electrophysiology. So what I'm really interested is, why do cardiac arrhythmias occurs in some hearts? And by using an animal model, a mouse model with spontaneous atrial fibrillation that I developed with my mentor, Dr. Stephen Marks, we were able to understand sort of the mechanisms of why some of these animals develop complex arrhythmias such as atrial fibrillation, and we've also been able to use different animal models for other studies such as ventricular fibrillation and ventricular tachycardia.
The research that I do now focuses on the impact of neighborhoods on cardiac outcomes, including readmissions after an acute coronary syndrome presentation. It builds upon the idea that there's something that's called a post-hospital syndrome.
I'm currently mentoring 6 different fellows in 6 different projects at various stages. Some were developed by the fellows themselves, some were projects that we had available that really needed help, and I am struck by their expertise, their engagement, their enthusiasm, and the productivity of those fellows has been striking.
In the setting of COVID, we had the opportunity to apply for an AHA grant to help us fund a clinical trial relating to antithrombotics in the setting of COVID patients in the ICU. We put together a study including participants from various divisions, including those from the public health school, and have started a randomized trial hoping to understand whether anticoagulation therapy can help improve the prognosis of these patients.
So I'm interested in advanced heart failure and transplant with a specific interest in sex differences in both management and outcomes, and then sex-specific issues such as pregnancy after heart transplant.
We currently at Columbia publish a peer-reviewed manuscript or abstract every working day, and it's because of the fellow contribution that makes all of this happen.